So this podcast has to do with percent composition. And we're going to find the percent composition is pretty easy as far as math goes in chemistry. It's probably one of the easiest things we do because it's something that you've done before in your math class. And percent composition is simply, whenever we talk about percentage, we always mean part divided by whole. So again, percentage always means this. So in chemistry, if I want to know the percent composition of sodium chloride, if I want to know the percent composition of hydrochloric acid, or the percent composition of phosphoric acid, we have compounds, and compounds are our whole. What are compounds made of? They are made up of a bunch of elements. Alright, so our example is simply going to be this. I want to know the percent composition of phosphoric acid. So we have a compound, and this compound is made up of 3 different elements. So we're going to have 3 different percentages. We're going to find the percent that is hydrogen, we're going to find the percent that is phosphorus, and we're going to find the percent that is oxygen. So in each of these cases, the whole is simply going to be our molar mass of our entire compound. So we kind of might go over here, and we're just going to do, we have 3 H's, and we have 1 P, and we have 4 O's. So up here we're going to do 3 times 1.0079, and for phosphorus we're going to have 1 times 30.974, and for oxygen we're going to have 4 times 15.999. Alright, so for hydrogen we're going to get 3.0237. And for phosphorus we're going to get 30.974. And for oxygen we're going to get 63.996. Alright, so when we add these all up, we get a value of 97.9937 grams. And that is simply our total, or our whole. So over here, when we do our percent composition, we're going to have 3 equations. For each of these equations, the whole is the same. So our molar mass goes in the denominator. So 97.9937, 97.9937, and 97.9937. And if you've kind of written stuff out like we did over on the right hand side, we're simply in the top going to put our elements. So of that 97.9937, how much of that is due to hydrogen, how much of that is due to phosphorus, how much of that is due to oxygen. So hydrogen contributed 3.0237 grams of that total. It's part of the whole. Phosphorus contributed 30.974 grams of that total. And oxygen contributed 63.996 grams of that total, so part of whole. Alright, the last thing you might do is, I added times 100 up here. Again, when we divide part by whole, you're going to get some kind of decimal value, and you can multiply that by 100 to make a percentage. The other thing you can do is just move the decimal 2 times, and that will make your 100% as well. So now we're just going to calculate these answers. And for hydrogen, we're going to get 3.09%. And if you could, I would like percentages to be rounded to the hundredths place. And that's just kind of the way chemists do it. And there's no rhyme or reason for it. It doesn't mean significant figures or anything, but that's just, we round to the hundredths place. And for phosphorus, we're going to get 31.61%. And lastly, for oxygen, we're going to get 65.31%. Alright, and a great way to double check your work is, you should be able to add up your 3 percentages, and their sum should be 100%. Sometimes with just rounding, you might get 99.99 or possibly 100.01. If we add these up, we're going to get 100.01%. But as long as you're within 100th of 100%, you should know that you did your math correctly. If you were to add up your percentages and you get something like 85%, you have done something wrong, and you should go back and double check your work. But that is percent composition, simply part over whole. And we're talking about molar masses, so what mass does the element contribute, and what's the total molar mass of our compound.